The tool that we chose to present was Mypy. I'm Tyler Farsinger.
I'm Will McCann.
So Python is a dynamically typed language. So variable types are checked at runtime and not compile time when you run your code. This can lead to a lot of runtime errors that are difficult to debug and just make it a lot bigger hassle than it needs to be. So Mypy is a tool that was created in 2014 to help limit the errors that you get, and is seamlessly integrated into IDEs and the terminal. And it was created by the Python community.
So some technical details about Mypy are that it allows for both dynamic and static typing within Python. So Python introduced type hints as a way to kind of specify what type of variable should be. So within dynamic typing, this involves when the developer does not add type hints to their code, and variable types must be inferred dynamically by Mypy before the program is run. And also static typing involves when the developer adds type hints to their variables and functions in their code, similar to more traditional programming languages, and Mypy is able to use these type hints in order to check the types of variables. Which brings us to the two main technical algorithms that we're going to be talking about. The first one is type inference that Mypy uses, which involves determining the types of variables that do not contain type hints. And it does this using flow-sensitive type inference, meaning that the types of variables are determined depending on the control flow of the program. And then another technical algorithm is type checking, which involves inspecting variable types, return types, and class inheritance structures to ensure that every type aligns properly. And type checking is done using multiple methods. The first is by parsing your code into abstract syntax trees. And then Mypy is able to use these trees to verify variable types across different parts of your code. And another way Mypy performs type checking is by formulating your code as a constraint satisfaction problem. It formulates the constraints using the variable assignments, the type annotations, and operations within your code, and then it solves these constraints using a constraint solver. So Mypy works particularly well when the developer chooses to include type hints in their code. So if we see on the left here, this function signature has type hints for the person and number parameters. So person should be a string, number should be an int. And we can see in the first example, if we call the greetPerson function with a string as the first variable and an integer as a second, Mypy will like this and the code will run perfectly as it is intended. However, if we try to call the function with an integer as the first parameter and an integer as the second parameter, Mypy will actually produce a warning saying that it expects a string instead of an int because we've added those type hints to the function signature. So it will prevent that error from occurring. And on the right there, we also have another example of how you can add type hints to your code, specifying that in this bank account class, we should say for in the deposit function, the amount should be an integer, withdraw should be an integer, and overdrawn should return a Boolean. That way, Mypy can check that you're using these types correctly. However, where the tool can tend to struggle sometimes is when the developer does not add type hints to the code, and the tool is forced to infer the variable types. So if we're looking at this example down here, there are no type hints added to this function. So if the developer were to call this function using a say a string, for example, there's a good chance that Mypy would not actually catch this error. And also, if type hints aren't added to a function signature, Mypy will actually skip the function as a whole. So we don't have any type hints on the signature of the generate combinations functions. So Mypy will actually give you a warning saying that it's not going to analyze any of the code inside of that function.
I will now give a live demonstration on RoboFlow. RoboFlow is a code base that helps do computer vision. So the first file that we're going to look at is the classification file in this load model function. So if I open up my terminal, like I mentioned earlier, I will run Mypy. So in order to run Mypy, you just type Mypy, And then this follow imports equals skip. This is if there are possible imports that may cause errors. This just skips over those imports. And then the file name. So I will type in classification.py. And so if I run this, you can see that there are no issues found in the one source file, which is classification.py. So if I go in here and I change this name and make it a string, and then I go down here to where name is mentioned again, and I try adding integer like 1, and then I rerun Mypy, you can see that you get back one error for the types for string and integer. Another example that we have within the same file, down here for this function, we will make it so it expects the return of an int. However, the return is a json.dumps, which will be a string. So if we try running it again, you can see that the return type of int was incompatible with the return type of string in the object, which is exactly what we expected from Mypy. Another example that we have is in this project.py file. So this type ignore assignment right here on this line pretty much lets you to ignore the assignment and bypass almost this whole entire line of code. It's a pretty cool feature that Mypy allows you to do, just so if there's a specific part of the code that you don't want to classify to a certain type, or it's too difficult to classify it to a certain type, you can do a type ignore and skip that part. So to run this code and test it with you guys, I will switch to that file. So again, just type in Mypy. The follow imports skip just allows you to skip any imports that you may not have installed. And then this project.py is just the file name that you want to run Mypy on. So as you can see that there are no issues found in this file. Now, as I mentioned, this type ignore lets you skip almost this whole entire line for if there's a particular reason. So if I get rid of this type ignore and I try running Mypy again, you can see that we get an error, and that's exactly what we expected, because you're ignoring this assignment in total, which basically ignores the whole line. So when you delete that, it will run this line, and that's where that error comes from. So similar tools. So another similar tool to Mypy is PyType. PyType is a static type checker just as well as Mypy is, that checks and also infers variables. The big things about PyType is that it is far less strict and the types can actually change within functions. And then Pyrite, which was created by Microsoft, is also another static type checker. And the key things to Pyrite is that it's a lot faster than Mypy, and Mypy currently quits as soon as it finds an error, whereas Pyrite will not quit, but it will just log that error.
So to wrap everything up, some of the benefits that Mypy provides are that it allows for early bug detection. So before you run your program, it's able to statically check it and catch anything before anything actually runs. It helps for improved readability because it enforces developers to use type hints within their code to specify what types variables should be. And it allows for easier refactoring of your programs as well. Some of the downsides of Mypy, though, are the introduced development overhead of having to add type hints to your variables in order for the tool to work effectively, the performance impact of having to run the tool before you execute your program every time, and the fact that it can generate some false positives where it says that your program has no errors within it, when in actuality there are a couple bugs that the tool wasn't able to catch. But overall, Mypy is a very helpful tool that easily integrates within a Python environment that can be used to help catch runtime errors before they occur.